Financial maths in our exam question can sometimes prove confusing or difficult, especially, well, what formula are we using? What are we applying? So first, let's have a look at the overall view in your exam question. How do we recognize that what we know what formula to use? If we are talking about once of payment, we are using the formula, just straightforward compound interest formula. Then the other type of situation very often is about conversion of the interest rate, yearly to monthly, yearly to weekly, yearly to quarterly. And then the next scenario is when we have many payments. When we have many payments, we have two options. Now, the SN formula, so the formula for the sum in geometric sequence, will work always. In all of the scenarios, we can use that formula. But as well, we have amortization formula. Now, that formula only works first when we are talking about debt. So we are going from having a loan, having the money, not to have then that money, that debt. And then very important, it has to be at the end of the period. However, the SN formula will work here as well. And in this particular question, we're going to be looking at both of them and applying them. So let's have a look. Sophia and her partner take out 25-year mortgage with a monthly interest rate of 0.279%. They make equal monthly repayments of 1,647.75 at the end of each month. So many payments and at the end of each month, so we know we have two options. They make the first repayment exactly 1 month after they take out the mortgage. So we know those two are our option. Now, the amortization formula is extremely straightforward when we are using it. Now, SN formula can prove challenging. And what is challenging when it is applied in financial maths question? Well, what values are we putting in place of A, meaning the first term, the place of R, and in the place of N? And that's what sometimes can prove challenging. Usually in this exam question, that's what we have in the first part. What we have to do here is that we have to write down the first three repayments in this case, so the first three terms. Here I've created a table that helps you to deal with that, whether it is like here's situation of mortgage or whether we are going from not having money. So when we are trying to have money at the end, usually it's about investment, creating some form of a fund at the end of the period. So here basically we can divide that into two different type of scenarios. Again, very important, is it the beginning of the period or is it the end of the period? If it is the investment, meaning going from not having money to having money, we therefore use the straightforward, our compound interest formula, as you can see it. When we are talking about having money, so having that loan in our account, and going towards not having that debt, therefore we change that formula. We manipulate that formula to read for P being a subject. So that's the main idea, but that's where they are coming from. And as well, because usually we have to write those terms, sometimes the first three, sometimes the first two, and then the last two. We need to know how that sequence is created. That's the reason here I have term 1 and term 2, so that we have an idea. Okay, so let's apply that knowledge here. So the repayments, when they take out the mortgage, all the repayments are in the future, isn't it? Because 1 month from now, 2 months from now, year from now, 5 years from now. So they are all about F. So that's the future money. So in place of F, here we're going to put the repayments of 1,647.75. Now, I everywhere means the same, means the interest rate. So, and they were very good because they gave us that interest rate of 0.279. Let's not forget that I, it's not expressed as a percentage, but as a decimal. Oh, that should be 2, not 7. 279. So we have to move that decimal point even further. And then T, when we are looking at T has to do with the period. So here we are looking at the end. So we are looking at this part of our table. So first term will be what? On top of the fraction 164775 divided by 1 plus the interest rate. So it will be 1.00279. And that first term will be to the power of 1 because it's only for 1 month. After 1 month, they are repaying it. And as you can see it, I'm showing you here that the second term will have power of 2. Then the third term will have what? Power of 3. So it's just a matter of repeating that. And we have all the terms that they were looking for. 279 to the power of 3. Okay, so we have first, second, and third. Okay, now next part. So therefore, we have to work out the money that Fia and her partner borrow for the mortgage because that's not what we are told. We don't know how much they borrowed. We only know how much they are repaying. So if I am applying SN formula, so let's get that formula. 1 minus r to the power of n and 1 minus r. So I do have the first term. That will be the first term. What about r? So r in all cases will be the same. 1 divided by 1 plus interest rate, so 1.00279. Then I'm saying n is always all the periods. So in this case, n is what? 25 years multiply every month, so multiply by 12. So that's my n value. And then I have my first one. So all I need to do is to replace the letters in the formula. 1647.75 divided by 1.00279, that's the A, multiply bracket 1 minus the R, 1 over 1.00279, and that fraction is taken to the power of n, which is 25 years multiplied by 12. You can multiply it. And then everything divided 1 minus, and again, R1 over 1.00279. And here is simple. We put all of that in the calculator, press equal, and we get our number 334563. So that's application of SN formula. What about amortization formula? Now, from amortization formula, what I'm looking for, I have that A repayments, but what I'm looking for P. So I just need to change that formula. Here I have a multiplication sign. So that means that formula will be reading A divided by my fraction I, 1 plus I to the power of t over 1 plus I to the power of t minus 1, and that will give me that value of P. So the monthly repayment, again, 164775 divided, and then my fraction line, my interest rate 0.00. Now, what is the difficulty here? When you are putting it in the calculator, just make sure you don't omit any zeros because that's sometimes the problem. And the time is what? 325 multiplied by 12, that will be 300. 1 plus, again, interest 0.00279, again to the power of 300 minus 1. And again, when we put that in the calculator, we're going to get the same value, 334563. That's how much they borrowed.